Hi class, I wanted to talk to you today about how to run an ANOVA in Jamovi. So what I have here is our stat survey that we took at the very beginning of class, and I wanted to ask a question. So my question here is, does the year, so the year that somebody is sophomore, junior, or senior, so we only have 3 levels, does that affect the distance that somebody is, that somebody lives away from all of that? So maybe we think that like sophomores don't come as far, but maybe seniors do, for example. That might be a hypothesis that we have. I don't really have a direction on this, so, and anyways, a ANOVA, so there is no direction. I'll test. Some of the things that I can do always at the beginning, it's nice to explore. Let's look at our descriptives. So I am going to look at year and distance. So you can see here that year is not working for me. All it tells me is that I have 16 data points in there, or students in this case. I also have distance. It tells me my mean and median. One of the things that's kind of interesting that we can do is we can do a split by. Let's see if that works. It does. So here it shows me that we have how many people that we have in each group. Sorry, I'll make that a little bit bigger. So our ends, so we have 6 sophomores, 3 juniors, and 7 seniors that have filled out our distance variable. You can see here that there might be a difference, right? So the mean for sophomores is 89, the mean for juniors is 63, mean for seniors is 98. And you can look at the minimum and the maximums if that's of interest to you. So there may or may not be a difference here, right? So if I were just to go, oh, is there a difference between how far away sophomores, juniors, and seniors live from campus? You can see that there might be a difference based on the mean, but we don't know if that's statistically significant. So here's where I want to run my ANOVA. So I have my ANOVA. The one that we're going to use is the one-way ANOVA. And here I'm going to put in my dependent variable as being distance. So that's my continuous variable, right? And I'm going to put in year as my grouping variable because I care about the differences between these 3 years. Variances, we don't have to assume. I think it makes sense to assume because we're going to assume that there are equal variances here. That gives us a few more degrees of freedom. We should check on that, but for the purposes right now of what you're doing, I don't think it's necessary. We're going to exclude cases analysis by analysis. We can have our descriptive tables, which just show us the same thing that we already found up here in our descriptives. You can plot it out because that might be helpful to see. A homogeneity test is good because we want to see if our variances are equal. And I'm going to save the post hoc test. So let's go ahead and interpret our one-way ANOVA. So here we have our dependent variable, which is distance, the F ratio. If you remember, we're trying to look at the differences. So if you remember, our F ratio is the variation between our samples, so that is between our sophomores, juniors, and seniors, divided by the variance within our samples. And we want our variance between our samples to be much bigger than our variance within the samples, because then we can say there is a difference between our groups. If that is true, right, there is a difference between our groups, our F ratio would be higher than 1. Here it's 0.325, so that's a lot less than 1. And so we assume then that there isn't a difference. We have our degrees of freedom 1, which is our between group degrees of freedom. Our degrees of freedom 2 is our within group degrees of freedom. So we can talk about how we calculated those things. And then our p-value. What we're looking for here in our p-value is a probability of obtaining that f value that is less than 5%. This probability, if you were to change it into a percentage, would be 73%. So this is a very likely outcome, which means that it's not statistically significant. So since this is so likely that they came from the exact same ones, right? If we think about our null hypothesis is that these 3 groups are the same. We cannot reject the null hypothesis because our probability is pretty high. And we can see this in our group statistics, right? So you can see the, or descriptives, sorry. You can see the means, right? It seems like there might be some differences, but if you look at our plots tell us a lot. It tells us what our means are, right? You can see these means in the little circles. And what these error bars are showing us is where 95% of our values will lie. And you can see that the juniors have a lot of variability. And that's probably because we only have 3 juniors in our sample. So this variability may make it so that it's not really different from the other 2. So these, in general, the mean looks pretty similar, and the error bars, or the distance between them all, looks pretty large. So we're not going to find an effect here. The last thing is just to check whether or not, so in variances, we can assume that they're equal or don't assume that they're equal. Homogeneity of variance test, this one here, is checking that assumption. Here, we actually want to have a high p-value, because if we have a low p-value, then that tells us that we are, right? So if we have a low p-value, that means that these are not the same level of variance. But here it's saying that we do have this similar levels of variance. So that is your one-way ANOVA. Again, key things that you want to look at are your p-values. The way that we are going to write this up, right? So if I were to write this, up, one quick and easy way to do this is to write something like this. So in my results section, according to the one-way ANOVA, so that's the type of test, right? Completed with year in school as the independent variable. We might want to call this a participant variable. Your research method book calls it that, which I kind of like. So I'm going to change that right now to a participant variable. And distance away from school as the dependent variable. We do not have a significant difference between groups, right? Because I knew that because my probability was higher than 0.05. When I'm writing this up, I have my F test. So the F tells me what type of test it is. For my F, I have to put in the degrees of freedom. The way this works in Jamovi is to take your degrees of freedom 1, put a comma, and then show your degrees of freedom 2, equals 2, and then you put in your statistic. Oops, sorry. So my statistic here is 0.325, and then I'm going to put in my p-value. Probability, and that should be italicized, is equal to 0.73. Then I interpret it. Thus, year in school is not associated with the distance that students live away from campus. Or I could say, something like this: the distance that students live away from school is not influenced by the students' year in school. Year in college, let's say. So there's a couple of different ways I can write this up. This is just one way. But I think the big thing to note here is that you're going to explain it And then you're going to discuss what does that actually mean. So that's what you're going to have in your results section. All right. Hope that helped.